Hello everyone. Today we are going to study 3-bit asynchronous counter. So first observe that in this figure, as we are going to count 3-bit as we are going to study 3-bit asynchronous counter, so we require 3 flip-flop A, flip-flop B and flip-flop C. And notice this thing also that we are using toggle type of a flip-flop, toggle A, toggle B and toggle C. And all these toggles are given as logic 1. Okay, see this logic 1. And because it is a asynchronous counter, so the negative clock is given to flip-flop A only. Output of this flip-flop is working as a negative edge triggering for flip-flop B, and same is the case with flip-flop C. Okay, this thing I have already covered in the yesterday's class. Now, suppose that initially all flip-flops are reset. So, QA, QB and QC will be 0, 0 and 0. Consider it as a reset state. Now, in step 2, negative clock is given to flip-flop A. See this figure. So, QA will always change its state at each and every negative clock. Keep this thing in your mind. So, QA initially it was 0. Now it will change its states from 0 to 1. Notice that this change is positive. So, this positive change, will it make any change in flip-flop B? No, it will not make any change in flip-flop B because flip-flop B will be triggered when QA changes from 1 to 0 because this is negative. Again, this concept I already covered in the yesterday's class, but again let us revise. Okay, so in the step 2, QA will change from 0 to 1 because this is a positive edge, so this will not make any change in flip-flop B. When flip-flop B is not changed means QB will remain same. When QB remains same, flip-flop C will also remain same. Means flip-flop C output, that is QC, will also remain same. Okay. Now let us move to the next slide. So if you see this, only QA has changed, QB and QC remain same. Now come to step 3. Again at this negative clock, QA will change from 1 to 0. 1 to 0. As you notice that this 1 to 0 is negative change in QA. This negative change in QA will make flip-flop B QB state to change. Okay. Now QA will change from 1 to 0. QB will change from 0 to 1. Okay. QB will change from 0 to 1. Now if you notice that this QB is positive change. So due to this positive change, flip-flop C will not get triggered because flip-flop C will get triggered if and only if QB will go from 1 to 0. But class, in this case, QB is going from 0 to 1. So QA always change at each and every clock, as you can notice, and QB has changed from 0 to 1. But QC has not changed. Okay. Now again in the next clock, QA will change 0 to 1. As you can see, this 0 to 1 is positive. Okay. So this will not make any change in QB, means QB will remain 1. When QB remains 1, means this line is very important. Since QB is same, hence QC will remain same. Hence QA always change each and every clock. QB has changed from 0 to 1. Because this change of QB from 0 to 1 is positive change, hence it will not make any change in this QC. Okay. Now again next clock QA change 1 to 0. Because this 1 to 0 is a negative change, so this negative edge change of QA will compel QB to change from 1 to 0. Okay. So QA here, QA will change 1 to 0 QB120, and if you notice that QB120, it is again a negative change in QB, so this will also change our QC, because QC will be changed when QB take a negative edge. Okay, so QC has changed from 0 to 1. Okay, now let us move to the next slide. Again, at the next clock, QA changes 0 to 1, because this is a positive change in QA. So this will make no change in QB. No change in QB means no change in QC. Here I have written very important. Keep this thing in your mind. No change in QB means no change in QC. So QB and QC will possess its previous state, that is 101. Only here only QA has changed. Now again we can see that QA changes 1 to 0. This will change QB from 0 to 1. Then same will happen with QB. QB will not change. Why it will not change? Because QB is positive, taking positive edge triggering. So QC same, as you can see in box 6, QC is 1. So same in box 7, QC is 1. Okay. Now let's see the next slide. Now here again QA changes 0 to 1. Due to this positive edge, QB will remain same. QB same means QC same. So in the box 7, if you see, it is given 111. 111 means decimal 7. Okay, decimal 7. Now in step 9, QA will change from 1 to 0. Because this is negative edge triggering change in QA, this will make QB to change also 1 to 0, because again this QB is taking negative edge triggering. This will compel QC to change as 1 to 0. So now in box number 9 you can see that QC, QB and QA is 000. It means that this is decimal 0. Now the whole procedure is repeated. As you can see, this box number 9 is same as box number 1. If you see that box number 1, the count was 0, and same count is 0 in box number 9. Now the same process is repeated again. So students, this was all about our 3-bit asynchronous up counter. Up counter means here the counting starts from 0, then 1, then 2, then 3, 4, 5, 6, 7. Then after the 7, we have counted again 0. Means when the count is going up, it is called up counter. Okay. Now, I want to give you the brief idea of down counter. Now students, down counter means first it will count 3, then 2, then 1, then 0, then again 3. Means counting is from higher number to lower number, means in decreasing order. So class, the process is exactly same as up counter, but there is a slight change in the diagram. The clock, you can see, it is again negative. This is again same as previous, but in the previous figure QA was acting as a negative clock for flip-flop B. But if you can notice the change, here QA bar is acting as a negative edge for flip-flop B. Okay, keep this thing in your mind. So whenever QA bar is connected to a negative edge clock to the another flip-flop, it will act as a down counter. Okay, now let us understand the procedure. It is again very easy. Okay, now class, suppose this is the clock. See this timing diagram. This timing diagram is very important. Suppose this is the clock given to flip-flop number A. Okay, as I have marked arrow at the negative edges of this clock, it means flip-flop A is triggered when negative clock is coming. Can you see here? Okay, now again come to the timing diagram. Okay, here I have written one line that QA transition, note this thing, QA transition from 0 to 1 is equal to QA bar transition from 1 to 0. Means if QA is changing from 0 to 1, by default QA bar will change 1 to 0. Okay. Now rather than drawing the QA bar diagram, I have directly drawn the QA diagram. Okay. Now at this negative edge of clock, QA, suppose initially QA was 0. Can you see here QA is 0? Okay. Here QA is 0. Here QA is going up like 0 to 1 at this negative edge of clock. Okay. Now again it remains same. Now at this QA changes. Okay. Now QA changes at this negative edge of clock. Again QA changes at this negative edge of clock. Now if we draw QB, QB will change when QA is going from low to high, or you can say that flip-flop B will be activated when QA is going from low to high. Okay, so this is flip-flop B output, low to high. Again it is same here. Then when QA is going low to high, again it is changing, and again it is changing when QA is going low to high. Okay, now if we put a dotted line here, you can see QB0, QA0, QB. So that is what I have written here, QB0, QA0. Now again I am drawing the dotted line from here where my clock is changing. Then QB, QA, 1 and 1. Okay. Then again I have drawn dotted line like this. Then QB, QA, 1, 0. So if you can notice, it is 0, 3, 2, 1, 0. So the counting is now down counting. Okay.